Chat is disabled for this live stream. Well, welcome, guys. I'm not sure why that's happening. Yeah, I just seem to have computer problems left and right. Again, I had to figure out how to set up my computer, and I had to get Thonny installed. I was also working on some community notes and some other stuff. And today, I want to work on this screen. SST77 Micropython driver. So I'm working on the ESP32-S2 diagram, and those are coming in the mail. But right now I'm looking for the ST7735 driver, and here it looks like it's here. ST37. This is a modified font is necessarily for displaying text. Some font files are in guys repo, text wrap option, graphic tests. Okay. And is this for Micropython? Awesome. So we should just be able to download this. So we'll download the code. Hope you guys are doing well. I do need to, off screen here, for some reason, check why on earth chat's disabled. But not that. Usually people don't. And is this for my... usually people don't chat, but I still want to get it set up. So I have these solid core wires, which have been pretty invaluable when working on breadboards. Oh my goodness. There we go, there we go. YouTube Studio. Why did I change? Inception. I cannot see the content. Live, there we go. Manage, there we go. Close captions. Nope, it does not want to allow chat for some reason. Chat's disabled.
Turf tax.
Okay, it works.
Said. Test.
Whatever, I got TTS turned on.
Turf tax. Said. Test.
It's just my OBS. Alright, so what I have here is the SST 7735 driver that I'm going to be downloading. Download zip. There we go. And we're going to be installing it on the board. So we will extract all these just to ST7735. I'll have that memorized by the end of the stream. A lot of things that are detail oriented, it's easy for me to lose track. So when I'm studying for things or working with items, it's helpful to I like to make diagrams because that's the equivalent of my notes. And so now I'm going to have to open this file because it won't let me. Downloads. And here we are. Okay, so I have Thonny. Thonny is pretty cool. I used to use UPyCraft or Micropython Craft, but I've since switched to Thonny because it broke a couple of times and I couldn't get to work. Okay, so I think I need to do file save as on the Micropython device. Yeah, and that is ST7735. The reason there's 100 reasons why I like MicroPython. One of my favorite reasons is that the libraries or the drivers are written in plain text. So if I were to unplug this board and plug it into a computer that didn't have an internet connection, I could fumble my way through the REPL environment in MicroPython on the board and figure out what the code is doing. I don't know of any other microcontroller, any other programming language that for microcontrollers that can do that. Yeah, there's CircuitPython as well. There's probably some, but literally the source code is on the board, and for rapid prototype development, it's my favorite. And also with C types and some other things that the MicroPython community does, it makes MicroPython just amazing, especially for someone like me that yes, it's cool to optimize something, and I can do that even within MicroPython. So I will be doing an in-depth review of MicroPython versus C++, some other programming languages to see, but I'm gonna have to do it very detail oriented, and I'm gonna have to have help on it. But let me just open this up. So we can take a look at the code for ourselves. See what is ST7735 doing? Okay, so it's importing machine, and inside machine has pretty much all the pins. Um, time, math, import, square root. Okay, so this says that the rotations, they even left some notes for us. Cool. So these are the rotation values. So clamp, okay, so they're clamping TFT color, TFT object. And then to initialize it, okay, initializing the pull down resistors. Color data is a 2 long byte array. Invert color, RGB, text. Cool, 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 cool. This looks straightforward. This is pretty long. How long is this? It's 1,000 lines of code. All right, so we have it loaded on the board. Let's go ahead and hit import ST7735. See if we get an error. No, okay, so let's do dir and see what's loaded into memory or the loaded objects. And this is directly from the REPL on the board, so that's what's cool. Read, evaluate, print loop. So this interaction, it's almost like a shell, and I used to say that I opened up a shell or whatever. So what is that word or what is that verb? So I REPLed into it, because usually I use SSH as like I SSH'd into it, but for this I REPLed into it. I guess that's what we're using. Okay, so let's look at the object ST7735 that we imported. And these are the ones inside of it, which pretty much there's nothing else here. Okay, so rotations. Okay, okay. So there was no error, that's good. And graphic test. Let's open up graphic test. So open on this computer. Yeah, let's open up graphic test. From machine import pin, baud rate. So SPI. So I was streaming on Twitch earlier and I forgot this term. It's the SPI interface. So baud rate, test lines. How is it initializing? I'm trying to see how they initialize the pins. Oh, here they are. So the TFT equals this. So it's 16, 17, and 18. So let's look up TFT. I could look at the documentation, but what's so cool is that I can literally just look inside of the module, I believe it's called, because library in Python you call a library, but in MicroPython I believe they're referred to as modules and or libraries. So, but modules seem to be the best word that I found, colloquially, um, because you can actually compile a library for MicroPython. But okay, so initializing. Okay, so it's the SPI 80, the DC. Reset. ACS 1, 2, 3, 4. I might have to look at the documentation. Yeah, what do the docs say? So reset pin connections for the ESP32. Okay, so let's take a look at that. So I have on my board, I think I need the 4 quadrants. I'm going to use that one. Yeah, that's a little bit better. Okay, so we need the reset pin. The reset pin is usually pretty important because it will tell the board that we're trying to communicate with it. I've had kind of touch and go luck when it comes to trying to get a screen to work on Micropython. Oh my goodness. These shears are... I'm gonna have to vacuum. All right. So it's saying that we want the reset pin to 17 and 16. So let's see what we have on here. I made this diagram for this reason. One didn't exist for this board. So they're saying 16 and 17. I didn't specify. 16 is just it can do pulse width modulation, so it doesn't really matter. So sure, why not? I'm going to pull this up on the other screen if you guys want to see it. I have it on my website, Open Muscle, which I will go to real quick. So resources, and this is it. I'm going to put it in chat just in case you guys want to follow along.
Turf Tax said,
Isn't that so awesome? Dude,
ESP32-S2-mini-by-wemos-pino-ut.
that's awesome. That's awesome. Okay, so we are going to import ST7735 in boot.py, 16, 17, and 18. So let me also pull up the website. You guys can see it on one screen. Actually, no, I could just refer to it in the screen, but it's not as easy. There we go. So let's, oh my goodness, I don't have Greenshot. Greenshot is one of the tools that I use to screenshot. Okay. So pin 16, okay. And pin 16 is top row outside. And it is the first one after ground. Okay. And I do believe I took a picture of this. I'm gonna have to do that again real quick. I need all of the screens. One moment. There we go. Okay, so screenshot that, or took a picture of it. So on the left side we have ground, which is correct. With ground we have VCC, and then we have the clock, which they say is pin 14. Pin 14 is located on the inner, but I'm going to use pin 12, closest on the left side. Okay, pin 12. There you go. Now you can see it. No. Yeah, I'm correct. Pin 12 on the outside. And we're going to put that into SCK, which is the third pin here. Okay, so we have the clock. To get Notepad open. So ESP32. So pin 12. And we have the ST7735 and GPIO12. And we have this to pin 3. Pin 3. SCK. Awesome. And there's only a couple. What do they have here? They have 3 pins, 16, 17, and 18. 16, 17, and 18. So the only 3 pins that you need to get this working are the reset pin, the DC pin, clock pin is mandatory. I wonder how they're doing the clock. This is gonna error. This is gonna error, but it's fine. So 16. 16 is A0. So the DC, we're just going to pick as pin 11. Pin 11 will be DC. And it's right next to 12. I probably should be adding some resistors here. But that's why I like ESP32-S2s, because they're relatively inexpensive. And 16 is DC, which I need to look at my phone. This is why I need so many screens. SDA or SCK. Oh my goodness, I think it needs to go to DC. I'm going to ask ChatGPT. That's why I have ChatGPT. One second while I get this. Okay, trying to hook up. SPI ST7735 TFT screen on a ESP32-S2 with Micropython, and I need the pins, but I am told to connect the SDA to pin 13, but I don't have SDA on the board, on the screen. I just have, which ones do I have? This is what I like about ChatGPT. GND, VCC, SCK, SDA, which I think that's what it is. RES, RS, CS. The terminology can sometimes be a little confusing, don't you? Oh, yes. Very. A little. They undersold it. Oh, that's my Raspberry Pi. I clicked on the wrong one. And now I'm frozen. Now that I get on it. Ground is the ground pin, VCC, of course. SCK is a serial clock connected to the SPI clock on the ESP32-S2, which I did. I kind of have to define it though in software. SDA is the MOSI. You can connect SPI MOSI pin to any pin. The SPI MOSI pin on the ESP32 board's documentation for the appropriate pin. Yeah, the MOSI or the miso soup. So on the ESP32, yeah, it just really doesn't matter, I don't think. Yeah, but the CS chip select. No, it's not helpful. Yeah, that's why I'm stringing this. Sometimes it just doesn't make sense. Okay, so we have the 3.3 volts already done because the left side of the board has the 3.3, the right has the 5 from the USB. Reset pin is 17. Yeah. Confusing. So GPU 12, so SCK, so I have 12. I'm just going to do 11. Okay. Let's just randomly figure this out. The next pin over for the board, if you guys want to see it. The next pin over, so I have pin 12. Here, let's see the full screen. Pin 12 is the clock. Pin 11 is the next one over. And then we're just going to do pin 9. Okay, pin 9. And keep our documentation. So 12 is pin 3. GPIO 11 is pin 4. SEA. GPIO 9 is pin 5, which is RES. And we're going to do 7. The next one. Oh, and I have all these off by 1, which, not much can happen, but okay. So I got these kind of all plugged in on the left side. Pin 7, GPIO 7 is on pin 6, which is RS on the board, GPIO 5, pin 7, which is CS. Okay. And we've ran out of colors, so I'm just going to use yellow again. I actually have one just laying over here. So, yeah, if you work with breadboards, it's a really good idea to get these solid core wires. Get a couple of the female jumpers, but for the male jumpers, just use solid core wire you can buy. This is what I have, the two fang solid single core tin copper wire. So yeah, it's a good addition to have. And there's one pin left over. Perfect. Okay. So we have our board pretty much set up. So let's go to the 4 quadrants. What in the heck is that? Okay. Just trying to make this a little bit bigger. And you guys don't need to see me. Okay, so we have the board there. Let's open up Thonny. So it's pin 16, 17, 18. So according to the website, which let's just copy and paste this into our notepad. This is what the website is telling us, which isn't very helpful. So the reset pin is 17. So they are defining this graphic test is the example code that we have. So in this example code, they just said that they're using SPI to connect, I'm guessing. Oh, SPI equals the baud rate at the top. There we go. I can read. Okay, SCK, so the clock is 14. Yeah. So let's save this onto the board. It's gonna run it when I save it, so let's change the values first. So we have SCK, so it's a clock. This is gonna be pin 17, right? SCK 12. So this is pin 12. MOSI pin is 13, which is SDA, which is here. So SDA will put MOSI. It's helpful to know that they mean the same thing. So that would be pin 11. Pin 11. MISO pin is 12. They don't have 12 in here because there's pretty much no reason to master in, slave out. Master out, slave in. So it's just the slave. Yeah. I don't don't quiz me on why this is the case. But these two pins are usually the two communication pins. So SDA is really the only thing we're looking for, which in this case is considered MOSI, since it's defined on this board itself on this screen. It's getting an input, so it's a slave input, I guess. So that's called SDA. So I wish, yeah, it's good that they have MOSI, but maybe I'm wrong. We'll see. We'll see shortly. So MISO, it shouldn't matter. This is set to pin 12. I'm going to use an arbitrary pin value here because one that isn't being used for anything crazy. Let's do an inner pin. Let's do pin 4. Oh, so you guys can see it. We're going to use pin 14 as the other one, so on the inside row. Pin 14. And then it says 16, 17, 18. So what is a 16, 17, 18? So this is the TFT object that they're calling in. Here's the initialize. Okay, so SPI, and then this is the DC, reset, and then CS. So let's just take this and we'll copy it down here. Yeah. We'll just say TFT SPI ADC reset. This is what it is. All right. So graphic test. So 16, that first number. You know what? I really just. Yeah, I'm going to put these notes in there later. I mean, they probably should be there, but whatever. 16, 17, 18. So 16 is referring to DC. Which is yeah, usually it's DC, it's the DC pin that you want to use to communicate. So what is pin 16 on the board? Pin 16. Pin 16 is third on the right, not connected to anything. Okay. And then 17 is reset, which I do believe is RES, which is 9. Okay. 9. I'm just going to put this here. So this is ADC equals 16. A reset equals 9. And a CS will equal GPIO 5. ADC, a reset, which this is kind of dangerous because that's what they're called internally. So I should have a prefix on them. Nah. Nope, nope, not gonna do it. And did I add this R in it? R? I don't think this should be there. Whatever. So we will file save as Micropython device. We're gonna name this graphic test.py. And let's run it and see what happens. Not. It's probably going to give it error. Yes, so there's no font. That's fine. No module name sysfont. Fun stuff. This is a modified version of the driver for MicroPython. The font is necessary for displaying text. Some files are in Guy Carver's repo. If graphic text doesn't work correctly, try replacing init R. It is supposed to be R at line 8 to init G or init B or to init B2. You could also try RGB2, RGB false to switch to red and blue pixels if your LCD module shows incorrect colors. Okay. Yeah, sometimes RGB, what is it, BGR? They do it vice versa, reverse. TFT is another sample similar to Adafruit's sketch for Arduino. Off-screen buffer shows how you can use an off-screen frame buffer, which is an instance of frame buffer class. Tested on Raspberry Pi Pico, see number 9 for the pin connections. Okay, so Guy Carver, Micropython. And this says, we have no module named sysfont. And this is sysfont. No, let's just copy it and new, and we're gonna save it. Micropython sysfont. Fine. Okay, and then let's try to run this. Interesting. It's blinking. Hmm. So it looks like this is actually the sys font. It was probably sending the information, but yeah, let's just copy this into boot. And we will grab the very top two. And put that into boot. Okay. And we're going to run boot. Problem Donnie's backend. Exception while handling run. You may need to press stop or hard press your Micropython device. Enter again. Process ended with exit code 1. Okay, let's do it line by line. Import ST7735. And we'll enter this in. SPI. Oh, you guys can't see this. Ah! Just in case the screen does anything, I'll leave it down there. Okay. TFT equals this. Okay, so TFT dot R TFT.RGB true. Wait a second. Let's do dir TFT. Yeah, it looks like it is. Because I didn't do from It must have been loaded into memory. Sometimes this happens, which is okay. So the pins are wrong. Pin 11. Yeah, so from machine it imported SPI and pin. So okay, dir tft. Probably say nope, it has no object name show. Okay. Well, I need to pull up a different source. So why is it a modified version? Star. 129 stars. Let's do this one. Five years ago, wow. And this one, yeah, less than. What are the issues with it? This is the part of micro, at least sometimes my style of doing things. Um, I do believe I have the pins incorrect. Let's see if I can find an example. ESP32 Micropython, and we need ST7735 on ESP32-S2 mini. I wonder if anyone else has done the mini. How to get the S2 mini done?
Again.
Aha.
In this video, I am going to show you how to connect
This
a
is good.
1.8-inch color TFT display that uses the 7735 driver to your LilyGo
So the
ESP32-S2
display,
board
the
and
board,
use it
pinout
with
diagram.
CircuitPython. I will also share with you two simple programs I developed using this display to help you get. I connected it to this ground pin. The third pin
So
of
this is their pinout. So VCC to 5. Oh, they're doing to 5. Ground CS reset. Display board. Yeah. So MOSI is SDA. I'm having trouble with this one. I don't know why my brain can't wrap it around. So MOSI on the display it's called SDA. Yep. And it's connected to pin 35. I have it connected to pin 11. And it calls this A0 pin 16. A0 DC. Yeah, see, why is that called MOSI? It was called MOSI. SDA is called MOSI. But it doesn't matter because that's from the board, so it's just confusing me here. And these are backwards. Okay, ESP32, yeah, there we go. Then I'll have to have the ESP32. So confusing. Huh? That doesn't matter. They're the same. Doesn't matter what pins these are on the ESP32. I don't care what pins they are. Okay, so they say that display, and this is backwards too, but it's fine. CS is 34. In this video, I'm going to show you how to use this if you're a long-time lover of the channel. Okay.
The display is named CS. CS pin goes to the CS pin, gets them all together in this Adafruit circuit on our computer.
They're using
Be careful.
CircuitPython, which
the
is
third
fine.
pin of the display.
This is fine. It's a slightly different board too, but this should be enough information. VCC. My brain is just having a disconnect here. SPI. Let me put this on the board. Other screen. SPI. Is 12 is SEK. OC pin is 11. Meso pin is 14. Which doesn't really matter. The DC (16). Reset is 9. CS is 5. Interesting, guys. This is a tough one. ESP Micropython TFT. Oh, there we go. Lily Go ESP32. So connection, software, the GitHub page. Now that we know how to use the display in these using CircuitPython, yes, yes. It's always CircuitPython. Yeah, sometimes the ILI 9341, I've used that one before. Yeah, where's the ILI 9341? Might have better luck getting that one. Micropython ILI 9341. Okay, we're gonna download all this. Sometimes these are not the most entertaining things to do, but open with download with zip. Oh, did it twice, that's fine. And I'm going to extract all these. ILI 9341. So I'm going to leave these graphic tests in sysfont, and we're just going to open up the ILI 9341. Okay, file save as ILI 9341.py. Okay, and what do we want? XGLCD font we're going to want to open. And file save as XGLCD font. U requests. They must have been working on some networking stuff. Why does it say Circuit Python? Did I? Excuse me. Sorry, guys. Didn't need to cough in the microphone. Micropython. Yeah, I don't care about the touchscreen. This should demo fonts. I should really read this, shouldn't I? I'm just randomly trying things. It works sometimes. There we go, the no-touch library. For displays, NanoGUI supports. Yeah, I was in the right spot. Okay. Demo fonts. Let's open up demo fonts. Sucks you can't just drag and drop, but this computer, demo fonts 8x8. Okay. Pen, SCK. SCK is 12. MOSI pin, which is SDA, is 11. DC pin, which it doesn't have. This is what's so weird. CSRS, RES, SDA, SEK. Reset pin is 9. CS pin is 5. DC pin is the DC pin. What is 4 going to? Yeah, 4 isn't going to anything, so sure. Control S, and then just push this onto the board. Okay, file save as, then display off. This computer, Micropython device, demo illy.py. Might not get it this round, guys. It might be too tough, believe it or not. Display texts. Yeah. Sleep 15. I'm going to do some digging because I think I have my pins wrong. I'm not sure what they are. So, we shall see. Actually, before I give up, let me go to AliExpress and log in. Nope. Yeah, what's the last pin? Well, left to right, so I have that going. Yeah, pin 8's not being used, is LEDA. Micropython 1.77 TFT 14 pin. Here's someone. Someone's asking this very apt question. I got a 1.44 TFT, which is blah blah blah. LCD has 11 pins whose names are listed. Not connected. LED for background light. I think it's real SPI. I did some research. There are SDA, SEK. I don't think it's the correct one. I tested this, the ST7735. However, I don't know how to handle both MISO, so there is no output on my LCD. You'll need the following pins: SPI, clock, SPI data, MOSI, pin 8, data command is RS, pin 9, module reset, chip select. SPI clock and data are handled by your SPI object, otherwise hardware software RS, Chip select will be GPIO output pins. You're free to choose. And I might need to. GPI 0? What? Okay. Fun stuff, guys. They have a GPIO 0. Are you serious? Hmm. If not one, yeah, blah, blah, blah. Your code looks okay, but I would check the library for the LCD controller. If you look at the link you sent, it doesn't appear to have a valid initialize the screen object correctly. Well, this does happen. SPI, DC, CS, reset. Everyone's having issues, aren't they? These little guys can be frustrating. Let's try graphic test again. Make sure nothing is overheating. No. Mosi pin. Miso 14. Let's go back to the boot. Let's just run this. Keyboard interrupt. Okay, let's do boot. Nothing on the screen yet. My favorite screen, by the way, is the SSD1306. Okay, nothing appeared on the screen, so let's look at SPI. Yeah. Well, I'm gonna have to learn a little bit. The 7735. I'm gonna have to look up some documentation. Because these pin names sometimes can confuse me. But I should, in software, be able to define these pins. I doubt I'm having any issues with that. So I'm going to leave off for today. This is a little bit boring. I apologize, but it's a necessary evil. I'm going to do some research and hopefully make some progress in this next. I want to make a video on how to install these inexpensive screens. I have 3 different screens that I like. The SSD1306, which I have laying around. The This is called TFT screen. I need to figure out the proper name of it. And then the other screen, which is bigger. Micropython, I really enjoy. And dealing with 1.20, it doesn't seem to have too many mistakes. Well, there's always errors everywhere, but let's do I equals 100 for I in range I print I. Okay, yeah, so fun stuff. Python, MicroPython is pretty hilarious, but uh, I don't know any funny examples to show on the screen other than that. But I will leave you guys, and as always,